Dr. Benitex here. Let's talk about limiting reagent calculations. First, let's answer this question that says 80 grams of aluminum is placed in a solution that contains 40 grams of sulfuric acid. Hydrogen gas and aluminum sulfate are produced in the reaction. A part of the question says, identify the limiting reagent. And the B part says, how many grams of excess reagent is consumed in this reaction? The C part says, what mass of excess reagent remain after the reaction is complete? To solve this problem, first we have to write a balanced equation for the reaction. So we have that aluminum, which is Al, reacts with sulfuric acid plus H2SO4. You can also call this tetraoxosulfate 6 acid. So when these two react, what should be the formula for the product formed? Don't forget that aluminum is in group 3. It has a charge of 3+, Al3+. Then don't forget also that the sulfate ion here is SO4 2-. So the question tells us that one of the products of this reaction is aluminum sulfate. So we need to find the correct formula for aluminum sulfate. How do we do this? Now the power here is 3 and the power here is 2. So the 3 comes to the sulfate and the 2 goes to the aluminum. And the formula we're going to get is going to look just like this. We have aluminum sulfate, Al2SO4 bracket, there'll be a 3 outside, plus the second product according to this question is hydrogen gas. So we have H2. So next thing we are going to do, we are going to balance the equation. So looking at this particular reaction here, we can see that one atom of aluminum is here and we have 2 atoms here. So we can start by putting a 2 here to balance aluminum. So after balancing aluminum, we can now decide to balance hydrogen. We have 2 atoms of hydrogen here. We have 2 atoms of hydrogen. Hydrogen is balanced. Let's now balance sulfur. How many sulfur atoms are here? We have just 1 atom and we have 3, virtue of the bracket. So we can put a 3 here to balance sulfur. So in the trying to balance sulfur, we have made hydrogen atoms to be 6. So let's make it 6 on this side also. So at this point, our equation is now balanced. So moving to the A part of the question that says, identify the limiting reagent. Now I'm going to show you the fastest way of identifying the limiting reagent. Whenever you are given masses, for example, we are given the mass of aluminum from here to be 80 grams. We have 80 grams of aluminum. And we are given the mass of sulfuric acid to be 40 grams. So the fastest way to identify the limiting reagent, you can do this as a rough work, is by dividing the given masses of the reactants by the molecular weights of those reactants, also taking into consideration their stoichiometry coefficient. For example, we all know that aluminum has an atomic mass of 27, while sulfur has atomic mass of about 32, hydrogen is equal to 1, oxygen is equal to 16. So these are parameters you need to know before solving this problem. So what do we do next? So we are going to divide the given masses by the molecular weights alongside the stoichiometry coefficient. So I'm going to say 80 grams here, and I'm going to dividing 80 grams by 27 times 2, which is 54. I'll do the same here. I'm going to be dividing the 40 grams here by the molecular weight of H2SO4, also taking into consideration the 3. And that is going to give me about, so that's going to give us about 294, because the molecular weight for H2SO4 is 98, and I'll multiply by 3, and that gives me 294. So after dividing, I'm going to compare the answers I'm going to obtain. So the one that gives me the smaller answer, that is my limiting reagent. What am I trying to say? So if I should divide 80 and 54, I'll get an answer. and I'll divide 40 and 294, I'll get another answer. So which of them gives me a smaller answer? That is going to be my limiting reagent. So you can see clearly that we are having 1.48 here and we are having 0.14 here. Compare these two answers, you can see clearly that 0.14 is smaller than 1.48, and that tells you that the limiting reagent in this reaction is sulfuric acid. Alright, so the A part of the question has been answered. So the limiting reagent in this reaction is sulfuric acid. Now remember, anytime you figure out the limiting reagent, the other reagent there becomes the excess. So it is clear that the excess reagent in this reaction is aluminum. So I can decide to label it this way. I can say limiting reagent, capital LR, and the excess, capital ER. So I have identified both reagents. So we are done with the A part of the question. Let us now go straight to the B part of the question. Now the B part of the question says, how many grams of excess reagent is consumed in this reaction? Don't forget that the excess reagent will remain after the reaction is complete. But that doesn't mean that it did not participate in the reaction. It took part in the reaction. So the B part of the question is asking us, how many grams of excess reagent was consumed? Or in other words, how many grams of excess reagent was used up in this reaction? How do we get the answer? Now this is how to do it. You are going to do a simple stoichiometry that connects the limiting reagent with the excess reagent. A very simple stoichiometry. You are connecting limiting reagent to excess reagent. Now, if I'm using standard chemistry language, I will say convert grams of limiting reagent to grams of excess reagent. We can do that together, right? So from the balanced equation here, I can say that 294 grams of H2SO4 will always react with 54 grams of aluminum. Therefore, what amount of sulfuric acid was given to us? We are given 40 grams, remember, right? So you say 40 grams of H2SO4 will react with what amount of aluminum? So you're going to cross multiply 40 multiplied by 54, and I'm dividing by 294 grams of Al. So when you calculate this, this is going to give us about, so this gives us 7.35 grams of aluminum. What does this mean? This simply means that out of the 80 grams of aluminum that was provided, only 7.35 grams of aluminum took part in the reaction. So we are trying to figure out the amount of aluminum which did not react. So we're going to have that total aluminum, which is the excess, is equal to 80 grams as given to us. Now, this is the amount of aluminum that was used. Used Al is equal to 7.35 grams. So now we are looking for the unused aluminum. That is the amount of aluminum remaining is going to be equal to 80 grams difference 7.35. That is 80 grams minus 7.35, and that gives us 72.65 grams. 72.65 grams of aluminum. So this is the amount of aluminum which did not react. So in summary, the A part of the question was asking for the limiting reagent. So the limiting reagent is H2SO4. Then the B part was asking for the amount of excess reagent that was consumed in the reaction, and we did our stoichiometry and we got it to be 7.35 grams of aluminum. So this is the amount of excess reagent that was consumed in the reaction. Then the last thing we did, as for the C part, we calculated the amount of excess which remained after the reaction was complete. Since we are given about 80 grams total and about 7.35 reacted, so the amount of unreacted that will be left is about 72.65 grams of aluminum. So this is the amount of excess which remained unreacted. Let's now go to the next question. Methanol is produced from the equation: suppose 356 grams of carbon monoxide and 65 grams of hydrogen are mixed. What mass of methanol can be produced? What mass of excess reagent remain after the limiting reagent is used up? To solve this problem, let's first balance the chemical equation. Alright, so this is the equation for the reaction. So to balance this equation, we are going to put a coefficient of 2 for hydrogen, because we have 4 atoms of hydrogen, that is 3 plus 1, 4 on the product side. So to balance it, you have to put a 2 here to make it 4. All other atoms are balanced. Let's now go straight to the given quantities in this question. So we are given that 356 grams of carbon monoxide. So we have 356 grams of carbon monoxide. And we are also given that 65 grams of hydrogen. So these are the given quantities. The A part of the question says, what mass of methanol can be produced? Before we can ascertain the amount of methanol that can be produced from this reaction, we have to first of all figure out the limiting reagent, because it is the limiting reagent that will determine the amount of methanol that can be produced from this reaction. Don't forget what we did in the previous problem. How did we determine the limiting reagent? We simply divided the given masses by the molecular weights alongside their stoichiometric coefficients. So let's try that one more time. So we're going to have that 356 that is given here. I'm going to be dividing this by the molecular weight here. Carbon is 12, C is 12, and O is equal to 16, and H is equal to 1. All right, so now let us sum it up. So carbon monoxide is going to be 12 plus 16, which is 28. So I'm dividing this by 28, and I'm dividing this by hydrogen is 1, 1 times 2 is 2, 2 times 2 is 4. Let's divide and get our answers, then we'll know which one is the limiting reagent. So we are going to obtain 12.7 moles here, and we're going to obtain 16.25. So let's compare these two answers. Which one is smaller? We can see clearly here that the smaller answer is 12.7, and that belongs to carbon monoxide. So it's very clear that the limiting reagent in this reaction is carbon monoxide. Now, once you have identified your limiting reagent, you are going to do a very simple stoichiometry that connects the limiting reagent to the product under consideration. So what am I trying to say? I'm trying to tell you that the carbon monoxide here is going to determine the amount of methanol that can be produced in this reaction. So what am I going to do next? I'm going to do a simple stoichiometry that connects the limiting reagent to the product. So this is my connection. I have carbon monoxide connecting methanol. Alright, so this is the stoichiometry. From the balanced equation, I have that 28 grams of carbon monoxide will always produce, the molecular weight here is 32 grams of methanol. Therefore, 356 grams of carbon monoxide will produce what quantity of methanol? They're going to cross multiply. So 356 multiplied by 32 divided by 28. So I have 356 multiplied by 32 divided by 28 grams of CH3OH. And this is going to give me 406.86 grams of methanol. So this is the amount of methanol that can be produced from this reaction. So we are moving over to the second part of the question that says, what mass of excess reagent remain after the limiting reagent is used up? Now, this is what you're going to do. Now, we know that our limiting reagent is carbon monoxide, limiting reagent, Lr, and our excess reagent is hydrogen. So don't forget. So I'm going to relate the limiting reagent with the excess reagent, and this is how I'm going to do it. From the balanced equation here, I have that this is 12 plus 16, that's 28. I have that 28 grams of carbon monoxide will always react with 4 grams of hydrogen. So therefore, 356 grams of carbon monoxide is expected to react with what amount? Cross multiply 356 multiplied by 4 divided by 28, and this is going to give us 50.86 grams of hydrogen gas. This is the amount of excess reagent which participated in the reaction. Now let's now go back to the original problem. So we are given that mass of hydrogen is equal to 65 grams. That's the amount that was given in the problem. So this is the total amount of hydrogen that was given, and this is the total amount of hydrogen which participated in the reaction. So what quantity did not react? What quantity remained after the limiting reagent was consumed? This is how to do it. So we're going to say mass of H2 65 grams, then mass of H2 used is going to be equal to, find the difference. So mass of H2 remaining, that's going to be equal to what? 65 minus 50.86, and that will give us 14.14 grams of hydrogen. So this is the amount of hydrogen which remains unreacted. So we are done with the B part of the problem. Next problem is a typical objective question on limiting reagents. The question says 1 gram of magnesium is burnt with 0.56 grams of oxygen in a closed vessel. Which reactant is left in excess and how much? To solve this problem, first we have to write a balanced equation for the reaction. So we have that magnesium Mg burns in oxygen O2. When it burns in oxygen, what's going to be the formula for the compound formed? Now we all know that magnesium Mg is in group 2, Mg2 plus. We have oxygen is also in group 6, O2 minus. So the formula for the compound that will be formed here is going to be MgO. That's magnesium oxide. Now, since we have the same magnitudes here, they'll cancel out and we have MgO as a formula for the compound. Now, this compound formed here, we are going to balance the equation. So how many atoms of Mg? 1. How many here? 1. How many atoms of oxygen? 2. How many here? 1. So we have to put a 2 here to balance it. And we have to put a 2 here to balance Mg. So that's the balanced equation. Now, let's solve the problem. We are given 1 gram of magnesium. So we have 1.0 grams of magnesium. And we are given 0.56 grams of oxygen. We have to figure out the limiting reagent. Don't forget that magnesium is equal to 24. That's the atomic mass, and oxygen still remains 16. So what do we do here? We are going to divide the 1 by 2 times 24, which is 48. And we're going to say 0.56 divided by 32. That is 16 times 2. We are going to compare our answers to figure out the limiting reagent, and this is what we are going to get. Okay, so this is going to give us 0.02, while this is going to give us 0.018. Now, comparing the two answers, it is very clear that the smaller value here is 0.018, which simply implies that the limiting reagent in this reaction is oxygen. So it is very obvious that the limiting reagent is oxygen, Lr, and the excess reagent is magnesium. The question says, which reagent is left in excess? So the answer is what? Magnesium. And by how much? So we need to know the amount of magnesium that remains after the reaction is complete. Don't forget what we've been doing. We are going to convert grams of limiting reagent to grams of excess reagent. That is going to tell us the exact amount of magnesium which participated in the reaction. Can we try that out? So from the balanced equation here, I have that 32 grams of oxygen, which is my limiting reagent, will always react with 48. That is 2 times 24, 48 grams of magnesium. So therefore, 0.56 grams of O2, which was provided, will react with what? We cross multiply 0.56 multiplied by 48 divided by 32, and 0.84 grams of magnesium. So this is the amount of magnesium which reacted or that took part in the reaction. So what amount of magnesium did not react? So total magnesium that was given to us was equal to 1.00 grams. We all saw that. Now the amount of magnesium that took part, so use the mg here, is equal to 0.84 grams. So what is the amount of unused? Let's say remaining mg will be equal to about 0.16 grams of mg. So we've answered the question, and our answer is option A. Alright, so this is Delight Imperial Academy. This is Delight Imperial Coaching. I am Dr. Benitex. If you have problems on chemistry, feel free to come to my channel. I have several videos explaining several concepts in chemistry which are very difficult, and I do my best to make them very simple. So feel free to like my videos, feel free to share, feel free to watch to the end because they are going to be very beneficial. Let's head down to the next problem. It says 10 grams of hydrogen and 64 grams of oxygen were filled in a steel vessel and exploded. The amount of water produced in this reaction will be, now looking at our options are given in moles. So we know what to do. So let's start by writing out a balanced equation for the reaction. So we have that hydrogen gas, that is H2, combined with oxygen gas to give us water, H2O. Let's balance the equation first. So I'll put a 2 here to balance oxygens, and I'll put a 2 here to balance hydrogens. That's the balanced equation. Next, let's talk about the given values in the question. We are given 10 grams of hydrogen and 64 grams of oxygen. So we are going to divide each of these masses by the molecular weights here to know which is the limiting reagent. Let's try it out. So I'm going to have 10 grams here divided by 4, and I'm going to have 64 grams here divided by 32, and we are going to have 2.5 as the answer here and 2.0 as the answer here. So comparing the two, we can see that 2.0 is smaller than 2.5. Hence, the limiting reagent here is oxygen. So since oxygen is our limiting reagent, let me label it limiting reagent. This is our excess reagent. Since oxygen is our limiting reagent, the question is asking us the amount of water produced in this reaction will be. So it is oxygen that will determine the amount of water that will be produced in this reaction. And let's work it out in grams. So I'm going to do a stoichiometry that connects the limiting reagent with this particular product here. Let's work it out. So from the balanced equation, we have that 32 grams of oxygen will always produce, water is 18, that is 1 times 2 is 2 plus 16, 18, then 2 times 18 is 36 grams of water. So 32 grams of oxygen will produce 36 grams of water. So therefore, 64 grams of oxygen is expected to produce. I'm going to cross multiply 64 times 36 all over 32. So 32 cancels to give us 2. 2 times 36 is equal to 72 grams of water. Now the question is asking us how many moles, or let me say the amount in moles of water. I have the grams here, right? So I can convert it back to moles by dividing this amount by the molar mass. The molar mass of water is 18. So therefore, the number of moles of water here is going to be equal to 72 grams divided by 18 grams present in 1 mole of water, and that gives us 4 moles. So the correct option here is option C.